x. Shoot. Okay, I'm back. Alright, so secant squared equals 1 plus tangent squared x. Well, maybe I should call them thetas just for fun. So the sum of squareds makes me think of this tangent. So to make that happen, I'm going to let x equal 2 tangent theta. That way, x squared plus 4 equals 4 tangent squared theta plus 4, which is going to be then 4 secant squared theta. So it comes from this Pythagorean identity. Lets you let that. Okay, so that means this thing down here on the bottom is just going to be 2 secant theta. This thing on the top is going to be 4, whatever 8, whatever 4 cubed is. Well, I mean, whatever 8 tangent cubed, and then the dx we'll have to get as well, which is going to be 2 secant squared theta. Alright, so then I have my x cubed is going to be that 8 tangent cubed theta. I'm going to pause this for 1 second. Tangent theta is x over 2, which I'm going to use to make my triangle. So I have a crummy looking triangle over here. But if this is my theta, then if tangent theta is x over 2, that's opposite over adjacent. So that's going to make that guy x, that guy 2, and then by the Pythagorean theorem, square root a squared plus b squared, so it's going to be x squared plus 4, and I'm really crummy at drawing this, but I think I did it better on the solutions. There it is. Theos tangent theta is x over 2, and then by the Pythagorean theorem I got that guy. And then I also worried because this white guy was 4 secant squared theta, so I'm just going to call that 2 secant theta. So that's why I'm getting all of this. I'm just inputting everything. So maybe I should put that into this thing down here on the bottom. So square root x squared plus 4, which is going to be square root 4 secant squared theta like that. Okay, cool. Equals just 2 secant theta. So okay, so that was 2 secant theta. There's 8 tangent cubed theta, and there's 2 secant squared theta. Alright, so x cubed. There's my tangent cubed theta. The bottom gives me that thing, which is secant. I'm not worrying about the constants, I'm going to throw them back out front. And then dx, which we just said right here, is what I'm going to secant squared theta. D theta. I guess I should have put that here too. So that's where I'm going to put all this in, and then I'll put the constants out front. So from the tangent cubed, I got the 8. From the secant, the bottom, I got a 2. And from the dx, I got another 2. Alright, well then after that, so that's just me substituting everything in like I see. Now I'm going to go to these solutions here. I see everything kind of cancels off. Roll from tangent cubed. I see that I'm able to pull a tangent off of that to get my secant tangent. Leaving with the tangent squared. So there's my du right there. So I can, and it's the secant tangent, I can turn that into secants. So I did. Then I can make my substitution. Then I send everything back. Then at this point, to secant cubed, the way I'm sending it back is with this triangle. So the secant theta is going to be the hypotenuse over the adjacent. So there we go, hypotenuse over adjacent cubed, hypotenuse over adjacent. And I got all my constants in here. And that's it. I'm done. I think the main part is the setup. Okay, yeah, and then we make the triangle. The triangle comes off of that right here. The triangle is coming off of this thing. The tangent theta equals x over 2. See, so there's theta, opposite over adjacent, and then I can find it here. I did it better when I drew it. Tangent theta was x over 2. X over 2. Opposite over adjacent. Pythagorean theorem gives me that. Now that's pretty much setting everything up. So I don't know. Hope that helped. Okay, let me know.